Good morning. There we go. Thank you all for being here at 9 a.m. on a Amsterdam morning. I hope everybody enjoyed their evening last night. Welcome to this talk on advanced analytics. My name's Rick Pector. I work for MicroStrategy. I'm a software development manager based in San Diego, California. I've been with the company about 12 years and recently been a little bit focused on a little niche about advanced analytics. The title of this session, I think, originally was Advanced Analytics and Data Mining with MicroStrategy. I've kind of tweaked it a little bit to say Advanced Analytics Made Easy. Try and keep this a little more interesting this morning to try and engage you a little bit in some provocative comments. There's actually, this is the sixth time I presented in Europe. Anybody was in Cologne in 2005 here? Anybody who might have been in London or Cannes? More recently, one gentleman from Cannes. So I think there's some new material here that you'll find. We really have two sessions on advanced analytics today. In this track, the original title was Data Mining and Advanced Analytics with MicroStrategy. I will be focusing on advanced analytics and the data mining portion of that talk. This advanced analytics Made Easy, I'm going to the whole presentation, when you'll see it after the conference, you'll get it all in one, because I'm going to just flow the whole thing together. The latter part is going to focus on function plugins and R. And so I will be talking a little bit about our R integration in this talk, but I'll have more demos and information about that in the second talk this afternoon, which is in a different room, in a different track, in a different place, and you can't find it in your program because it got added late, so I call it a super secret stealth session. So probably the only ones that will know about it are either you here or anybody you tell. So if you want to tell people, that's fine. It's not really a secret. Okay, so what are advanced analytics and really what's BI? BI is about making decisions for your business, and advanced analytics is all about making those decisions better. And I'm hopefully at the end of this day you'll see that some examples of some things that can help you and your business do a better job with your BI implementations. I'll argue also that MicroStrategy is really an ideal environment for analytics. This is a schematic diagram of the platform with our data sources at the bottom, the user communities that we try to serve at the top. But when it comes to analytics, there's usually a separate user community. You typically have a group of people who may use different tools, may do different types of analysis. But ideally, if you ask any data miner or statistician, 50 to 75% of the effort is actually getting to a good data set. And I'd argue that with a well-modeled MicroStrategy project, you're well down that path to having quality data built on an enterprise data warehouse with data access in place and single version of the truth and all those other great things that the platform brings. I'd also argue that the power of these analytics should be made available to everybody in the organization and not just the 5 guys in the basement using a particular set of tools. And we allow that type of information to be delivered to all the various touch points that you've heard about at this event, and probably one of the reasons why you've come to use MicroStrategy. The real challenge then is really deploying the analytics into the BI environment and kind of bridging that silo. I'll give you some information today about how we can bring in these analytics in and describe what may be a little bit different than regular standard run-of-the-mill analytics, and what do we really mean by advanced analytics. Just to give you a lay of the land of the talk this morning and in the next session, we kind of break down analytics. It's a very broad territory. One challenge is it covers an awful lot of ground. Advanced analytics that I'm showing here are really kind of functions, advanced functions that you might be able to do within standard MicroStrategy metrics. These are things that are available in our out-of-the-box function library. We have over 300 functions built into the platform. I'll contrast that a bit with data mining, where you're really building a model, and the model is the thing that then you deploy to generate scores. And so we'll talk about data mining features of the platform in this session, may spill over into the second session. And then finally, I'll talk about function plugins, which allows us to complement whatever you don't see on the other 2/3 of the chart. And we are excited about our support from for R that we launched earlier this year, and I'll tell you more about that, especially in the second session. A little bit of what's going to go on here, too. I know some of you may be statisticians. In fact, how many show of hands in the room, how many people are statisticians, or you consider yourself a data scientist? And then how many people are not really just here because they've heard about this stuff, and everybody else is probably somewhere in between. So I used to do this Wizard of Oz, Dorothy, how can we get Dorothy's business working better? And the Emerald City guy was the DBA, really mean guy. And then we'd pull back the curtain and show that the wizard really, wasn't doing anything that magical that you couldn't do yourself. And advanced analytics don't have to be intimidating. And the details are sophisticated, but the concepts can really be intuitive, and I'll try to convey that today. I'll let you be the judge of how well that works. I also hope you'll come away with a feeling that we have some compelling features here to offer, and you probably may not be aware of the capability you already own, because we bundle everything that I'm going to show you today is part of what we ship as an every unit item. There is no stats pack. There's nothing special to add. And I'll be careful to point out any add-on products like Visual Insight or things like that. But in general, all the analytics you see here are available to you at no extra cost. The question is, are these doable by anyone? And that's going to kind of take me to the first step. Let's talk about what are advanced analytics. And let's start with a definition. I am in Europe, and I apologize for being somewhat American-focused, maybe in some of my words in my talk. So how does the English dictionary define analytics? This is the official definition: pertaining to or proceeding by analysis. More importantly, I like the parenthetical part, as opposed to synthetic. Analysis and analytics really should allow the data to speak for itself versus creating something that may not be there synthetically. Now, earlier is Norman Manley here? Norman, are you in the room? I had dinner with Norman the other night after he had tweeted this tweet. I'm not sure whether that MicroStrategy understands what analytics means, or perhaps I don't. We don't agree on the definition. Fair enough. I did reply to his tweet because that's what we can do these days. And I gave him my best shot, then my humble opinion. Analytics, let the data speak for itself via the analyst who, with the right tools, is really only limited by his or her own talent. And I think that's really the key here. The data is what we should be exposing when we have an analytic, and the data should be able to tell a story, and it's really up to the analyst to be able to tell that story rather than create or fabricate or synthetically make one. Let the data speak for itself. So that's one definition, at least my definition, of what the analytics that you're going to see today are. What about advanced? What makes this stuff advanced? Well, one definition of advanced is anything not simple must be advanced. The dictionary throws out a definition that simple should be easy to understand and not complicated. As advanced has another interesting definition, placed farther ahead or forward or farther along. And so that kind of made me think a little bit, is advanced really relative or absolute? Is advanced just something farther along from where you are now? There's an Everlast song, and basically says, where you end up usually depends on where you start. And I think there is a lot of truth to that. If you've had a background in statistics, or if you've been trained in statistics, obviously you're going to be farther along the path than someone who isn't. Does that mean you can't do this, or is even advanced things totally out of your reach? I prefer that we should have more of an absolute definition, that it should be something that we all can agree upon when we say something is advanced, it is. Advanced should be something not that anyone can do. For example, usually in high school, at least in the States, if you were taking calculus in high school, that was the most advanced math class in the high school, and you get kind of credit for that. Anybody who learns Hungarian as a second language, I think there's no argument that is challenging and an advanced language to learn. I ski, and when you go skiing, you have the double black diamond runs, which mean expert only. And so this is actually me in Park City, and there really does drop off the side of the world there, a nice big bowl beneath me. And I'm not that great of a skier, but the signs tell you that if you go over the edge, you're going to risk breaking your neck. And I think that's kind of a good absolute scale on things, as well as the likelihood of me breaking my neck as I go over this thing. So I'm going to try and pick up on this approach of using the double black diamond, the skiing approach. We'll talk about things that are simple or advanced. I will make a proposal. You can argue with me or not of whether an analytic is advanced or not. Let's start simple. What analytics are not advanced? I think we would all agree 1 + 1 = 2. That's not advanced. Probably anything you can do on a calculator, not advanced. What about Excel? Now, some people use Excel their whole lives and maybe only use 5 or 10% of its capabilities. And I'd argue that the complexity of Excel and how advanced your work in Excel really depends on the type of formulas you can add to an Excel workbook. And let's use that as a starting point of having a formula. Let's see what formulas, at what point do we leave from being simple to advanced. There is a kind of an increasing degree of difficulty with formulas. And in Excel, you can have simple operators. Most people can do that. You begin to get to have ranges and operations, all the way up to, I put LinS down here. That is really what I would say is the experts-only part of Excel. Anybody ever use Excel's LinEst linear estimation function to do linear regression, multivariate linear regression? There's a few people in the back there I can see. So, I kind of put that, even though that isn't that hard, but in the realm of Excel users, yeah, that is probably near the top edge of the type of analytics you can do with Excel out of the box. Now, what about MicroStrategy? MicroStrategy, we're kind of like Excel. We have that formula, but our metrics have a little bit more than that. The formula, we always require somewhere along the path an aggregation function, because we are a BI tool. We understand your business and your hierarchy, so we want to be able to do a calculation, make sure that we start with it at the right level, and that we are able to aggregate that at a different level if it's used in a report in a different way. So we have two required pieces of our metrics, not just a formula, but also we understand where the calculation is supposed to start and where it can end. We have two optional pieces as well. We have a filter and a transformation that allows our metrics to be limited, let's say, into a certain scope or a realm. We also have transformations that allow us to do things like year over year, year to date, month to date. Now, a lot of people, some of these things are getting too advanced already. So let me back up a little bit. Let's talk about the simplest metric you could probably make, and that's just revenue. And I'm showing here that sum of revenue. The little tilde in the curly braces is the level that this is starting at, and we've defaulted this little symbol. Just means do it at the level of the report. And you'll see 3 grids on here, and each grid for revenue gives you a different number depending on what is, in this case, on the rows of the report, whether it's years or category or region. We know we can calculate revenue and give you the right answer for that aspect of the business with a simple metric. Another thing to take away from this, and I think this is simple, or we're going to have to call this simple because I don't think it gets much simpler. A metric is not a result. Really, you only get a result is when you take a metric and then you give data to it. We had to use this metric on a report to get answers. And that's the other kind of complicated factor, is that metrics just don't stand alone, they get used. This is a diagram from a colleague of mine, Spencer Davey. I don't know if anybody knows Spencer. He's one of our best consultants. He's in Australia. And he built this diagram that kind of shows how our metrics build from certain things in our environment and can be deployed elsewhere. If you like this, then you'll love this one even better. Really, when you get into MicroStrategy, and I do a lot of data mining stuff, but then I also get calls for data modeling, which in a way can be just as advanced and complicated as data mining and understanding your data warehouse and your schemas and laying things out correctly and doing everything that you want to have done right in a MicroStrategy project. And so I'll concede at the beginning that I'm assuming that we've got a MicroStrategy project in place, and modeling that data can be anywhere from an intermediate to an advanced activity. But I'm going to just take it on faith right now that someone's done that work, and we're talking about how we can add value on top of what's already been a well-modeled data environment. When we talk about advanced analytics, we typically think about things more than just our basic functions that you can do sums and counts on. In fact, to some, an advanced analytic is anything beyond sum and count. I've included on the screen here some examples of subtotals, where we can take a metric calculation and actually use it as a subtotal. Any metric can actually become an aggregation function in a subtotal. In our metric definitions, we have the 4 components. I even show a little bit of hypothesis testing, the heteroscedastic and homoscedastic t-tests. Let me talk a little bit more about that, and probably that's a good jumping off point for advanced metrics is hypothesis testing. But before I get into that, we probably need to talk a little bit about people. I'll argue that these days the analytical playing field is leveling. There's fewer barriers than ever before for people to get access to advanced analytics. It used to be that you needed to have a lot of training. There was a little bit of a, kind of an intimidation, ivory tower kind of effect. Literally these days you can watch a YouTube video and in a few minutes learn how to do an analytic or a calculation that you didn't know how to do before. And more importantly, the tools that you need Used to be expensive and esoteric. Now they're already bundled. MicroStrategy, as you'll see today, has some good native features. There's a lot of open tools, and I'll be talking about R. And really, in the past, where you needed to have a lot of software and some powerful hardware, really most of the people have at their fingertips the power that they need, and the software is also probably available and sitting there. And it really, most biggest distinction is really people. The success factor of analytics really depends on the analysts, more so I think these days than exactly which particular tool they happen to be using. When we talk about making decisions, because BI is about decision making, statistical decision makings by statisticians, they express their confidence about those decisions and probabilities. And so that's another probably step down the analytical path, the advanced path, is we're going to talk about probabilities. And let's start with an example, flipping a coin. If I flip a coin 10 times, about how many times should I expect it to come up heads? 5 times, right? In actuality, statistically, it will only get 5 heads about 25, a little under 25% of the time. And here's the histogram that shows the number of heads that you will have, from a simple binomial probability distribution. Well, statisticians use a tool called a hypothesis test. And basically, there's a null hypothesis. The standard hypothesis is there's nothing unusual going on, that this is a standard, nothing exceptional is happening here. So in our example, we're going to assume the coin is fair, because that's kind of the default place to start. And then statisticians decide whether to reject that hypothesis, and therefore the coin is not fair, or decide not to reject the null hypothesis. That doesn't necessarily mean the coin is fair. They just decided not to say that the coin is not fair, which is kind of a double negative. We do have various types of hypothesis tests. I won't go through those today, but just to give you a little example here, and to try and, for the non-statisticians in the room, statisticians usually try and set up a threshold at which they will reject the null hypothesis. In this case, I'm showing a bell-shaped curve, and if you're at any one of these tails, if my coin only came up heads once, or came up heads 9 or 10 times tails, that's probably not a fair coin for some reason, and that's what this hypothesis test would say. And if you're in the middle there, it says don't reject it. But now we're business people, and business people have to make business decisions in the real world, and I'll throw out a challenge to you. What if the wager is €1, and I flipped this coin and it came up heads 3 out of 10 times? Are you going to accept the coin as fair? And if you're a statistician, you probably will, because the null hypothesis was not rejected. Or are you going to reject it as unfair in spite of that, because it just doesn't seem right? 3 out of 10 doesn't seem like a very good feeling for me. Or would you pay to rerun the test? Maybe do a test a second time and see if you get the same result. Or, even better, run the test 100 times instead of 10. And then you'll have a much better chance of understanding whether this coin is fair or not. And it's probably the C and D options that is why you want a statistician, you want an analyst, somebody who can take this thing that might have been an ambivalent answer in making the real-world decision, and how could I get to a more solid answer? And by rerunning the test, let's say 100 times, now if you notice those bars are way out there, and it's going to be pretty easy to see whether a coin is really bad or not. And by the way, I just said the wager was €1. What if this was a month's salary or a significant revenue period of your business? That does raise the stakes, right? And that does change your interest level in getting this right. Finally, there is one little mistake on here. I only cared about whether, I have to pick heads, right? I don't care if it's unfair the other way. I really only care about the left hand rejecting, not the right hand, and I don't know if anybody noticed that, but that's another thing a statistician probably would have figured out, is that he would have really done his hypothesis test like that. Okay, enough about hypothesis testing. I will say hypothesis testing is an advanced thing, and that is a type of advanced analytic. Takes me back to analysts. There really are 2 types of analysts. Let me go back to people here. There are quants, and those is a term these days we use for people formally trained. Analytics is their profession. And I'll call analytical amateurs. These are people informally trained. Analytics is their hobby. Quants are in search of the truth. They're often found in the back office, tend to be methodical. They want a good model or nothing. They'd rather either have good answers, or they're not comfortable necessarily sticking their neck out without something to back up, letting the data speak for itself. They're definitely necessary when risks are high. You want someone who, if you're going to be issuing life insurance policies, if you're going to be looking for cancer, the effectiveness of cancer tests, you want to make sure you have people who know exactly what they're doing. And they tend to have an ego that's based on being rigorous and being able to do good work. I'll contrast that with analytical amateurs, a term that came in the Compendium Analytics books that's been out 5 years now. They're usually in search of an edge, and they're sometimes found on the front lines, tend to be unorthodox. If you've seen how many people have seen the movie Moneyball? Heard of the movie Moneyball, the book Moneyball? I think Moneyball is a good example of analytical amateurs, at least coming into power and enabling some good statisticians in the background to help them. But if Billy Beane wasn't an analytical amateur, that we wouldn't be talking about Moneyball today. Quants have a head start because literally they are farther along down that path, but that doesn't mean analytical amateurs can't also do advanced analytics just as long as they're properly prepared and do a little bit of an effort. I think in an organization, and even in the book, it even talks about you should have both in your organization, and you actually probably do. One last thing I'll throw out here and then get more back to analytics is there's a bit of a value pyramid with analytics. I had one customer tell me, if I'm making $1 million pricing decision for my business, I want to use $1 million tool. And it's hard to argue with that. And their pricing and saying the right price, especially across a large enterprise, is a tough challenge. We have a vendor here that has a whole session on price optimization. So that does put this at the kind of higher level. That's another reason why third-party tools, SaaSes, SPSSes of the world, those on the orders of tens to hundreds of thousands of euros a year, sometimes just to rent the software. And that's one reason why people do that, because the return on investment is in that level. Conversely, I'll argue, though, that as tools become more commodity and you have more access to them, you open up a wider level of maybe less valuable or less costly decisions, but decisions that then should be able to be made much more easily and freely if you just have the people who knew how to do them and take things to the next step. And so there's more opportunities for analytics today than ever before, mainly because you don't have this high barrier to justify a return on investment with lots of hardware and software. You can now literally crack open a book, watch a video, and start adding value at a very low level. And that's I think, what's really interesting about the industry these days, and why we've seen such a growth in analytics across so many companies. So that's enough about advanced analytics. Let's talk about data mining. Data mining is a process more than just a one-shot calculation. There's usually a realm of training and developing a model. By the way, having a well-defined goal, I can't emphasize enough how important it is when you start the process to have a well-defined goal, know exactly what it is you're trying to do. I've seen more problems happen because the goal wasn't well-defined or wasn't well articulated. If you ever work with me, that's my first question to you is, what business problem are we trying to solve? And if you can state that term in business terms, then we have a better chance of seeing what data and other things that we can bring to bear to solve those problems. You typically build a data set. Pretty much all data mining tools work on a big flat table, a big flat spreadsheet. Every column is a variable, every row is an item, a record, something you're trying to study and understand. Sometimes you have to convert those columns into other forms. We like to take numeric values and put them into smaller bins. If you know anything about ratings and age ratings, usually it's the 18 to 35 age group that is the target of advertisers, not just 23-year-olds, because they can actually get better prediction and better understanding of data by having a class that is in fewer, larger chunks rather than having many small chunks that are difficult to put a handle on. Once you have your variables, you're able to build your model, and that can be an iterative process. It should be very quick to get to one model, but it may take you a long time to get to the model, if you can ever get to the model, something that does something good. I'll argue that obvious stuff would already be known by a business. Any well-run organization should already know something that if it's obvious, you probably don't need a machine learning algorithm to tell you that. And that's why it's called data mining, not data picking gold nuggets off the ground, because data mining finds that stuff you don't know about, that it's hidden, and therefore maybe a little bit not as having a big of an impact on your business, or you would have known about it. Once you do have that model, deploying it and getting that out to your user community is a part we call scoring. And scores should be able to be delivered to anybody. And the person consuming that score shouldn't really have to be concerned with how it was created. They should just be able to look at that prediction, look at that forecast, and use it. Much like your credit scores. I think everybody knows these days you have a number out there that defines your accessibility to credit. In the States, we have 3 different credit unions. They rarely get the same exact number for your credit. Now, how can 3 numbers that don't agree be used to discriminate against me in ways that religion, gender, where I live, and other things can't? It's kind of an interesting analytic that's put out there, and very few people know how it's calculated, yet it really controls some of the most fundamental decisions of our lives. I think it's a good example of a deployed analytic that can be used even though you don't necessarily know what's going on in the background. A lot of questions about where does MicroStrategy begin and end. One of the toughest questions is, how do I know how far I can take MicroStrategy before I need to use some other advanced tool? In the data mining world, it's a little bit easier to define. Everything in red here are model types that you can create and score with MicroStrategy. So MicroStrategy, for instance, we have a decision tree algorithm, We have a decision tree algorithm, and so we can generate, using the CART algorithm, decision trees. We can also consume decision trees from other tools that maybe use different algorithms like C4.5 or CHIDE or other things like that. They still look like a decision tree to us. I'll contrast that with neural networks. We decided not to try and put the knobs and dials into our product that allows you to create neural networks because they're kind of finicky little black boxes. They really do need to know what you're doing, and we decided we're going to leave neural networks to the other more traditional data mining tools. But once somebody has created a neural network, we're able to bring that model into our environment, and we use a standard called PMML, the Predictive Model Markup Language, basically an XML representation of that model. And a neural network, when I read that XML, it tells me there's this many neurons, they're connected in this way, they fire at this point, and it's really just a mathematical exercise to score a neural network, even though I didn't create it. One last thing, the truth in advertising is there's a lot of different places to do this scoring. You can do scoring inside, I would argue, historically, 90% of the time you do scores. Typically, it has been done in the data mining tool. If you're using SAS, you send a bunch of records over to SAS, the SAS data miner scores records, and then what? Then it stays with the SAS guy, maybe. Maybe he writes a report or sends it out in an Excel spreadsheet. Maybe it gets uploaded into the data warehouse, and then a tool like MicroStrategy can report on it. We're seeing more and more, and even at this conference, other opportunities for deployment, including deploying into the database, and of course, what I'm going to be talking about, deploying into the business intelligence environment. We really don't care what approach you use. We are kind of Switzerland on this. We're not selling, again, all these features come included, so we don't have a vested interest in which one you use. We just want to make sure you use your analytics wherever it makes sense. We like to push calculations down to the database. And there's been some very interesting talks at this conference about how we can get better calculations with some of our database partners and the parallelism that they have. And so those are things you should always keep on the plate as well. Another thing guiding us as we've implemented stuff in MicroStrategy, this is from a survey of 700 to 800 data miners from Rexer Analytics. And it's been consistent with a lot of other surveys. There's really 3 main workhorses for data mining. You need to have the ability to do regression, forecasting a number. You need to be able to do classification. How do I predict whether a customer is likely to respond to a marketing campaign or might leave my business? And you want to be able to do some data mining-driven clustering, not typical CRM segmentation where you look at, driven by income brackets or geographic location where somebody segments in a guided way. I'm talking, when I say clustering, I mean an unguided, look at all the items and let their nature tell us what natural clusters are there, and we'll talk more about that in a second. I put check marks by the types of things that we do support natively in the platform, either, as you saw on the previous slide, scoring by ourselves or also being consumed by third-party tools. Also in this survey was another interesting chart about tool usage. And I'll mention, this is really a bit more of our plug for the PMML technology that we have. On this chart, you'll see that R has shown up not only in this Rexer survey, but there's a KD Nuggets survey. And I think somebody tweeted that they questioned whether R was really as popular these days as we're claiming at this conference that it is. If you go to KD Nuggets and if you look at their survey over the past few years, it's been pretty impressive, the growth that R has had. And I think it's unquestioned that there is a significant sea change going on in the community about not only R, but also open source tools in general. And the open source community, RapidMiner and Nime, both done just over in Germany, are some very cool and interesting data mining tools with graphical workflows that are available for free. Weka's been around for a long time as well. The average data miner in this survey, when asked, said they used 4 to 5 different tools. And I think that's an important thing. And one tool not on here is Excel, which is probably the #1 analytical tool in the world. My point is that, and our philosophy is, we shouldn't limit you into one tool. You should use whatever tool you want. And in fact, if you have statisticians, they have their favorite tools. They make their careers and money by being able to do wonderful things with those tools. We don't want to take those tools away from them. But we also want to make sure that we have options for incorporating and deploying those analytics into our environment. Okay, so let's talk about predictive models. Predictive models really are just a special kind of analytic. This PMML that I've talked about has a standard way to define how we can transform data coming in, how we can provide results going out. It includes a lot of descriptive statistics and information about the quality of the model that's accessible in a standard way. And literally, it just, kind of in the heart of a PMML model, there's a chunk of XML in the middle that could be a decision tree, it could be a regression model, it could be a cluster. And we just have inside our engine the functions that can parse and score and execute those, that analytic, just like it was any other analytic. This is basically the chart I went through before. Let's talk a little bit about what is a data mining model from a hidden variables point of view. The real key payoff of a model is understanding the hidden relationships between inputs and outputs. And typically when you build a model, you start with known information and things that maybe describe what you're interested in. And then you're looking at the results that you have, and you start with both sides of this to try and understand how to relate those inputs to the outputs. And that's basically what every data mining model tries to do. There's some hidden variables, and it's those hidden variables that actually gives you insight into your business, and I'll try to show you. Okay, so let's get into the data mining piece of this. I am about half hour. That's going pretty good. Any questions, feel free to interrupt if I say anything that's unclear, if anybody has anything to add. Let's talk first about forecasting, which tends to be the first rung on the analytical ladder, if you will. And we'll talk about forecasting using regression. Regression is sometimes known as ordinary least squared, curve fitting, and we include both linear and exponential regression techniques that basically try to fit a best line to a set of data. I like this quote from Carl Pearson from about 101 years ago now, that regression searches for the eternal and changing amongst the chaos of the transitory and illusory. And if that sounds a little flowery to you, hopefully in a few seconds you'll know what I mean. The simplest way to understand regression is a scatter plot. And I think anybody who's gone to school has done something like this. You've tried to find a best fit line through the data, and you can just kind of eyeball where it would seem kind of balanced to have that line, so you kind of an equal number of dots on either side of it. Well, software does that automatically for you, and it tries to minimize the amount of error. That's why we call it the least squared. We take these error bars and you square them, because a negative number and a positive number might cancel, but a negative times a negative is a positive times a positive, positive. When you sum those up, you really sum up the amount of error you have, and you try and minimize that. And that's the entire theory behind linear regression, is minimizing the amount of error between your line or the thing that you're trying to represent with the data and the actual data itself. Here's an example of a line that's clearly not a good fit. Its error bars are even longer. Here's the worst line, and this is kind of the default guess. If I just took an average of these data points, I could just probably, my worst forecast, at least somewhat educated, would be to say I predict something's in the middle there. And so how good is a fit is a question that we'll have, and I'll get back to that in just 1 second. When you define a line's defined by 2 numbers. One is its slope, how steep or shallow it is, and a constant, where does it hit the y-axis. Most of us had this in school, y equals mx plus b. It's that the slope, the m, the intercept, the b, those are the eternal and unchanging amongst the chaos of the transitory and illusory. And all data mining tries to do is those 2 numbers. When I read in a PMML model, that's a linear regression equation that with 1 variable, I'm really just looking for two coefficients, a slope and an intercept. And when I have those, I can predict any other. Give me an x, and I can predict any y. Pretty straightforward and simple. I'm going to call this intermediate, though. And it probably isn't easy, but most of us have been in college probably have done this. How good is the fit? Well, there's an R-squared value, coefficient of determination that describes how much of the variability in the data is understood by this equation. For this particular line, it's 0.72, 72%, let's say. There's a way to calculate R-squared. You'll have this in the slide. I'm going to go a different way, though. And by the way, understanding this R-squared value, I'd say, is a little bit tougher sometimes to explain to people. But obviously, 100% would be a perfect line. 0% would be a perfectly bad. Let me do a different way, and I will talk a little bit about Moneyball. I apologize if you don't know baseball. If I were just here and you were telling me about cricket, I wouldn't know what you're talking about. Baseball, and the theory behind Moneyball in short, was that you win baseball by scoring more runs than your opponent. And if you really want to improve your team, you need to find out a way to get more runs per game. And so one part of Moneyball was, what is the best predictor of runs per game? Now in baseball, the number one statistic in baseball is batting average. It's been around since the 1800s. It's been used. It's the thing that when the batter comes up to the plate, it's what they show up on the monitor. Batting average has been everything. If you look at a number of players and their batting average and the relationship between batting average on the x-axis and runs per game on the y-axis, it's another scatter plot, and we can draw a simple line through that. And I'm giving you the calculation here of actually how it's calculated, just in case you're not familiar with baseball. But basically, it's batting average is how many times do you get a good thing happen versus get a bad thing happen. And in baseball, if you have a good thing happen 1 out of 3 times, they call you a star. There are 2 other statistics that Moneyball brought to bear. And really, these statistics have been there all around, but it really kind of took until the 2000s for them to come to bear. And in fact, they'd been around since the 70s, but I won't get into that. One is slugging percentage, where you weight the hit by how many bases. A single is 1, a double is 2, a triple is 3, and a home run is 4. And you've kind of now weighted the power of a hit. Which, when you maybe want to think about your business, is there a way to take a statistic that you already have in your business and somehow give more weight to certain transactions or certain things? There's another statistic called on-base percentage, and it gives credit. Batting average doesn't count if you get a walk. If the pitcher fails to get you to strike out or commit an out, you can get a free pass to go to first base, or you have a struck batsman. You can get hit by the ball and get to first base. What the theory of Moneyball basically said is, we don't care how you get on first base, get on first base. And if you can get that leadoff batter to first base, you almost double the chances of scoring a run that inning. And that's kind of interesting. And if we just look at this, going back to regression and our squared values, you can almost visually see the dispersion of these data points. I've drawn some ovals here that try to capture, maybe with some outliers excluded, the general shape of the data. And if I kind of lay these inside one another, the tightest one is actually on-base percentage. Slugging percentage is second, and batting average is third. And this is, in a way, somewhat of a representation of that R-squared value. Forget about for Americans and baseball fans here, I include National League and American League because of the designated hitter. There's different statistics for those 2 leagues. Let's just focus on the total Major League Baseball column on the right. What we find is that batting average, as explaining runs per game, is only about 68%. It only really knows about 2/3 of why. Batting average only explains 2/3 of the reason why runs per game may be the way they are. But slugging percentage and on-base percentage are significantly higher. In fact, if we do a multi-linear regression and include 3 variables at once, we get quite higher. In fact, if I run the exact same analysis without batting average, I get the same numbers. And so, in fact, batting average is not a very good statistic at all. And one of the things the Oakland A's and Billy Beane found out, they actually combine these 2 things together, and if you just simply, it's easy to add 2 numbers together, somebody's on-base percentage and slugging percentage to OPS, 91% is the R-squared value for that, and that simple addition is something most coaches can handle in in the manager's box of understanding what player to select. And that's kind of Moneyball in 2 minutes. And here's the OPS curve, and you can visually see it as a tighter than the other ones as well. And that's kind of why this R-squared value becomes important. It's an interesting statistic. Hopefully that was clear to you, an interesting way to capture the R-squared value. One last thing I want to talk about exponential regression. Linear regression, if you notice the y-axis on this chart goes up linearly. Well, if you plot something on a log scale, notice our data got a little bit denser here. Those lines got closer together. And I can actually still use all the math with regression. It still holds. And when it goes into a little bit of a different format when you do that log of the y variable. But if you work through the math, there's still two numbers there. The slope and the intercept are somewhat more available. That slope is really more of a rate, like a compounding interest rate. I'd give exponential regression also an advanced setting. That's something probably more than people had in high school. Okay, so with one independent variable, we have a regression equation in this kind of y equals mx plus b form. Well, we can generalize this to more variables. And we can have as many variables as you want, actually, in a regression analysis. And you just simply add more terms, and the math still holds. And so MicroStrategy and the algorithms that we support are multivariate algorithms, and we generate multivariate regression models. Sometimes those are harder to understand. I'm going to give that an advanced as well, because it kind of deals with multidimensional space. Let me take you into a demo right now. We're going to create a predictive model with MicroStrategy. This is the workflow that we use. We're going to assume that we already have the data modeled in the MicroStrategy environment. I'm going to create a training metric. I'm going to run that training metric on a report. It's going to create my predictive model, which I can then go and deploy. So let me switch over to my MicroStrategy desktop. And this is with desktop. Currently, desktop is the place that we create metrics like this. What you'll notice in Visual Insight that's coming out in 9.3.1 is the ability to insert more generic functions in there. But what I'm going to show you here in desktop, and something that's a desktop-only feature, is something we call a training metric wizard. I'm going to insert not just a new metric. We have something called a training metric. I'll admit that training metrics are kind of a necessary evil. It's hard for people to understand. This is not the model. It describes what the model will be. It's going to generate a model, but it isn't the model itself. It has 3 basic screens. And this is the same for any type of advanced data mining analytic you want to do with MicroStrategy. You tell us a type of analysis. In this case, we want to use linear regression because I'm forecasting a number. You want to tell us what variables participate in the model. We went and said you clicked on revenue, so we put that as the thing you're trying to predict, a dependent variable. We use the other metrics that I have in this report, a month index that goes up a value of 1 for each month, and a month of year that is going to allow me to catch seasonality. The third and final screen is we're actually going to build a predictive model, and this tells us information about it. In fact, I'm going to call this one linear. Notice that we have an aggregation function. We're a BI tool. We could use this. This is at the month level, but if I ever wanted to use this predictor, let's say at the year level or some higher place, I would know how to sum up those values. So we give you full control over what type of aggregation function you'd want to use. And that's it. I'll go and click Finish. And this little window popped up and says, hey, we created a predictive model in the place you told us to. I'm going to just drag this guy over to the left here because I like my green diamonds are the real data. The red line is the forecast going ahead in the future. If you look over here in my report objects, I have this training metric that's sitting here. It's off the grid. It's not bold. But what is on the grid is this predictive metric. And that is what the red line that you see on the chart. And I can right mouse click and say View Predictive Model. And this shows me the regression equation that I have in place here that I've built on this data. Now, it's a little bit more complicated than y equals mx plus b. We have this month index variable. If I go to the Variables tab, I can see month index went at a certain time interval. It goes up a value of 1 each and every time. Month of year, we detected as categorical. It had a finite number of repeating values. And we automatically transform categorical variables in a technique that's very common in data mining to what we call indicator variables. So if the month of year is, with this variable month of year equals 2, well, if I'm in February, this binary variable is going to give me a 1, otherwise it's a 0. And once you understand that, I think I can go back to the equation now, and you can kind of see a little bit about what's going on. All these month of years are adders for kind of telling you the value of, let's say, a February. What month is missing here? January's not here. Everything's kind of like the straight line regression, all the Januaries would have lined up with each other. And now we take that line and we're going to put adders on it for what month of the year you're in. And so a February is worth 58,000 more than a January would be. And a December is almost $250,000 more than what a January would be. And that's a little bit of the hidden variables. This is interesting information about your business. I also know this month index, since it goes up a value of 1 each and every month, that my revenue is growing at a rate of 21,500 each and every month. That's interesting information for your business, and really that's why you want data mining models where you can understand the hidden variables and why they're working the way they are. One reason why I don't like neural networks is because they are black boxes and you can't really learn why they're behaving the way they are. And most analysts like to understand why their models do what they do. We also include quality information. We actually lay out the statistics here, the same as the Excel linest function. That was one of the things one of our early customers asked us to do. We do lift charts. We have a simulator that will allow us to exercise this model without having to run it on a report. And I can then kind of see the performance of this. This is executing inside MicroStrategy's engine, and we scored about 40,000 records per second. So if I had 1 million records, it'd take about 25 seconds to score them in our engine, so you can get a feel for performance. We also include a little mini data set we call model verification records. The stuff in white is permanently there with the model, including a set of known answers. The columns in yellow, we calculated on the fly when I opened this up, and if there was any mismatch, if I saw any problem with the actual data to the ones that would have been expected, we would have popped up a message saying, hey, there's a problem here. This is helpful, especially if you want to make sure you deployed your model correctly. If you're moving from one environment to another, you can have some comfort that the answers MicroStrategy are delivering, or if on this particular iServer, are the same as you had in the model development environment. Any questions or comments on that? Then one last thing I want to do, I'm going to go back here, I'm going to take my training metric, I'm going to edit it. Take it back, and I'm just going to switch it over to exponential regression. Leave that the same, and I'm just going to change the name of this to EXP. And I'll double-click to add it to our report. The training metric, when I put it on the grid, got executed, and then we replaced it. We took it off, and we replaced it with its predictive metric. I can right-mouse click and view this predictive model. And it has the same variables that we're familiar with, just the coefficients are laid out in a slightly different manner. Remember that the revenue was going up at about 23,500 a month. Well, now this is like a compounding rate. At about 2.3%. If this was interest in a bank, you'd be getting compound interest at 2.3% per month. And so this, we can actually look at the model quality information. If I actually go to the variables tab, I should have showed this earlier. We include detailed information about each of the variables, including model-specific statistics, that R-squared value. For the statisticians in the room, we also included the adjusted R-squared. We also include a hypothesis test result, the probability that if we have a high R-squared value, did it happen by chance? Why is this important? Imagine if I only had two points. Well, a line can only go through one way through 2 data points. And so the R-squared value would be 100%. But is that really the relationship here? The probability that that may just have happened by chance is rather high. There wasn't enough degrees of freedom for that line to go anywhere. You'd much rather have 10 data points and have the line miss it than only have 2 and assume that matches the relationship. So we include those values as well, and the R-squared value on this one I think is a little slightly less than what we saw with the linear model, and I'll try and get these on the screen, but you can kind of see a little faint, the yellow line is a little bit more of aggressive growth. It's going to assume that things are growing aggressively. And now you as a data miner would have to choose which one of these do I want to deploy. I think most people would tend to deploy the linear one just because it's easier to understand. But if you wanted to be aggressive with your business, you may be pushing your people harder if you deploy the exponential one. Questions or comments on that? I'm approaching the hour, and so I'm going to try and get through a little bit more. See if I can get through time series. By the way, yeah, a couple more things to go through. You can try this in, what I just showed you is in Tutorial, the standard out-of-the-box product that we ship. It's a real easy-to-find place in Tutorial, Public Objects, Reports, MicroStrategy Platform Capabilities, MicroStrategy Data Mining Services, Linear Regression. So you can find it there. There's actually a whole folder there of other stuff as well. We do something called tree regression, and it allows us to build more than one model at once. I've got an example for this that I've already got loaded in a dashboard that we've created via this. So this was done with Report Services. So this is a Flash dashboard. Let me show you the grid behind this. We have revenue, and just like MicroStrategy, you can go inside the data warehouse and figure out for the month of December 2006 in the region of the Northeast in the category of books what revenue was. We can go ahead and synthesize and create a forecast for that same intersection of product and time and geography. And we can use each aspect of the business to come up with its own unique model. And that's essentially what you see have happen here. There's really only two metrics on this report, revenue and a revenue forecast. But when I show you this in this graph matrix format, which is now even easier to do with Visual Insight, you have these charts. The area chart is the known data. The blue line going ahead in the future is the forecast. And we have 16 different forecasts here. And if you look at the blue lines, they all wiggle a little bit differently. And while we have 16 different models, these are all contained within a single metric. And that's a pretty powerful capability that we have. That you imagine if you wanted to build 16 models, build 16 training metrics, run it 16 times, that'd be a little tedious. We can do them in one fell swoop, and it's easy for us to do because we understand how it's just BI with a predictive flavor added to it. One of our customers, Corporate Express, a while ago, did this same sort of thing. They did over 300, if this is 300 different combinations of aspects of their business. They had, I think, 28 different regions, 6 product categories, and a couple different customer classifications. And they'd used a green line for their real data and a dashed line for ahead for the future, and they kind of show the R-squared value. This is a smaller version of a 300-page report that I'm showing. And so they kind of put that R-squared value right alongside their chart so people could give some idea how much confidence to put into that forecast. And again, this is just a single metric being used across a lot of the business for them. Let me head back to PowerPoint. PowerPoint. Here we go. So I would still also put all this stuff in the advanced category. This is something I don't think there's any argument with that. Real quick time series, and in 5 minutes or less, this will be interesting. Time series is a hugely broad subject, but people who love it will tell you that anything is a time series. You know, there's your heart rate, there's a Dow Jones Industrial Average. I like this one where you biometrically look at somebody's profile, turn that into, with a raster kind of scan, a line segment, and now you can use that to do face recognition and things like that. They even use it for brain scans, and putting a little fractal pattern there turns that image into a linear series of data points that can be identified for certain structure. And that's what time series does. It's a series of points taken over time. It assumes that there's a certain structure inside, and there's a single variable. You're using the thing itself to predict itself. This was very popular in World War II, especially when you're dropping bombs out of airplanes or depth charges off of ships. If you can predict where they are at the beginning, you can kind of have an idea of where they're going to end. And, but it's much broader than that. There are lots of different approaches to time series. We've already did a little bit of time series analysis with our regression. There's averages and moving averages. We have exponential smoothing in our product. And what I'll talk about in the afternoon is an approach with ARIMA that we can now do with R that I haven't been able to do before. And there's other things than that. So this is a pretty broad area. How How does time series analysis work? I'm going to get to you why exponential smoothing is what it is, but if I was going to just take data that wasn't trending, I could just average it like we saw before, and I could say revenue averages 10,000 a month, and that'd be pretty cool. That's just a constant predictive model. I would find the error, I could sum up those errors, and again, you're trying to minimize these squared errors, right? So that's in time series models, you try to minimize the mean squared error. Imagine if I had some different estimates. Instead of that 10,000, if I used 9,000 or 12,000, my mean squared error would be worse. Not surprising. What about data that has a trend? Well, you just can't average all the data, right? You're not going to pick up on that trend. Moving averages can help you do that, right? Moving averages is you kind of move a window here, it kind of captures the latest data points. Notice that this moving average always sums up the weights. We're giving equal weight to each three of these things that we sum over time. And when I put that moving average result, I do find that it is a bit better than just using a level approach. But moving averages aren't great. They're kind of like snapshots in time. They don't really understand the general trend. To do that, you need double moving averages, and you need centered moving averages to avoid lag. Long story short, with time series, you can get back to the y equals mx plus b form, where in this case we have the slope and the intercept, very similar to what we saw on the earlier page. Again, all time periods are weighted equally. And therefore, when we're going to use these averages, we tend to have these all sum up to 1, giving them all equal weight. Exponential smoothing is what we do have in MicroStrategy, and it's a little bit different. It kind of believes that near is dear. What happened to me recently is probably more influence than what happened a long time ago. And so imagine that we gave more emphasis to something that happened in the near term, let's say 2/3 of the weight and only 1/3 to the time period before. These events still sum to 1, but this is what goes on with exponential smoothing. In fact, formally, there's a value called alpha that determines how much weight should you give the near one, how much weight should you give the far one, and the software finds the optimum value for this alpha. Given all that, you have various types of time series models that we can now generate, and probably easier seeing graphically here. You can have data that has no seasonality, so that's this first column, and either a straight trend, an additive or multiplicative trend like we saw with the exponential curve fits. They also have damped additives and damped multiplicatives, and this is really in the real world. You have headwinds or you have currents, and your bomb doesn't go straight forever. We also have seasonal versions of that, where the seasonality can be added, and you can even see here, or it could be multiplied in. And time series, really what we do is it goes through and use each one of these templates, finds the best alpha for them, computes the lowest root mean square, and picks the best one. And with that, I'm out of time. I'm going to pause this discussion now until we regroup again at the next session. In fact, if I go to slide 4, I will let you know where we're at. Any questions? In fact, I'm just going to have to go here and say bink. Any questions before we break and then we reconvene at 11:30 to talk and finish more about both data mining models and also function plugins in R? Well, I'll be up here if you have any more questions, and I hope to see you at 11:30. Thank you.